Children, let's see further. Having understood what a quadratic equation is, how to write down the standard form of quadratic equation, and how to get the values of a, b, and c. Let's inch further in our chapter to understand what are the roots of the quadratic equation. To determine the values given are the roots of the quadratic equation. So right now there are many students who are thinking in their mind, sir, what exactly roots of a quadratic equation are? That must be going on in your mind. Okay, what is roots? Children, numbers which satisfy our quadratic equation, numbers which satisfy our quadratic equations are nothing but the roots of the quadratic equation. In other words, if I have to say the solution set what we obtain on solving our quadratic equation, the solution set what we obtain on solving the quadratic equation is termed as roots of the quadratic equation. On the other hand, if I have to say in some other way, the numbers which satisfy our quadratic equation are termed as roots of the quadratic equation. I hope you are clear with the word root. So let's determine what is the question. To determine the values given are the roots of the quadratic equation or not. So we have a quadratic equation in front of us. We have certain values also, and we need to check whether these values satisfy the quadratic equation or not. If they do, they are the roots, and if they do not, they are not the roots. So given quadratic equation is m square plus 3m minus 4 equals to 0 for m equals to 1, minus 2 and minus 3. 1 by 1 is what we need to substitute. So in the very first case, substitute m equals to 1. Now, whenever we want to identify whether the number is root or not, whenever we want to identify that the number is root or not, we always take LHS and solve it. If our LHS, on solving LHS, if we get RHS, then the number is a root, or else it is not a root. That means we need to take LHS, solve it. The final answer, if happens to be RHS, then it is a root, or else it is not a root. Substitute m equals to 1 in the above quadratic equation. So what the above quadratic equation will be, 1 square plus 3 into 1 minus 4. Mind you, this is my LHS. Mind you, this is my LHS. Substitute m equals to 1. LHS is 1 square plus 3 into 1 minus 4. 1 square is 1 plus 3 minus 4. 4 minus 4, which is 0, which is my RHS. Since LHS is equals to RHS, therefore, can I say m equals to 1 is the root of above quadratic equation. I can say it's a root of above quadratic equation. Let's go and check the second one, minus 2. So over there, we can say also substitute m equals to minus 2 in the above quadratic equation. What my LHS turns out to be, my LHS shall be m square, so minus 2 square plus 3 into minus 2 minus 4. Minus 2 square, 4. 3 into minus 2, minus 6. Minus 4. 4 minus 4 gets cancels off. I am left with minus 6. What is our RHS, children? Our RHS is 0. So can I say which is not equal to RHS? Since LHS not equal to RHS, therefore m equal to minus 2 is not the root of above quadratic equation. Now, also, I'll take the third one. Substitute what this time? M equals to minus 3. On substituting m equals to minus 3 in our equation, it is minus 3 square plus 3 into minus 3 minus 4. That's nothing but my LHS, children, mind you. That's nothing but my LHS. Minus 3 square, 9. Plus of minus, minus. Minus 4 gets cancels off. I'm left with minus 4, which is not equal to my RHS. Since LHS is not equal to RHS, therefore m equal to minus 4 is not the root of above quadratic equation. I hope my children must have understood what exactly we are talking of. If on substituting the value, if LHS and RHS are same, it's a root, or else it is not a root. Let us take one more sum. Here, what is a different thing which I have taken here? I have taken one fraction, right? So you can understand that, okay, roots can also be in fraction. Root can be any irrational number also, mind you. It can be an irrational number also, right? It can be rational, it can be irrational. It can have all the possible fractions, decimals, whatever. Real numbers, all real numbers. Same way, no change whatsoever. So we shall say, first one, substitute. First, n equals to 1. In above quadratic equation, what is my LHS turning out to be? 2 into 1 square plus 5 into 1 minus 3. 1 square is 1, 1 into 2, 2. 5 ones are 5, minus 3. 7 minus 3, answer is 4, which is not equal to my RHS, children, because my RHS is 0. Since LHS not equal to RHS, therefore n equals to 1 is not the root of above quadratic equation. N equals to 1 is not the root of above quadratic equation. Also, let's go and take the next one. N equals to half. Substitute. N equals to half. So what my equation will look like? LHS is 2 into n square, half square, plus 5 into half, minus 3. 2 into half square, 1 by 4, plus 5 ones are 5 by 2, minus 3 by 1. 2 ones are 2 twos are. So I'm left with half plus 5 by 2 minus 3. Even if you don't want to go for LCM, don't you try and take LCM. This sum is very easy. Half, the denominators are same. So 1 plus 5, 6 by 2. 6 by 2 minus 3, which is 3 minus 3. 3 minus 3 is 0, which is nothing but my RHS. Which is nothing but my RHS. Since LHS is equals to RHS, therefore n equals to half is the root of above quadratic equation. Let me solve the third one here, children. Let me solve the third one here. Right? What we need to do is we just substitute. Also, I have taken the third one here. Also, substitute. N equals to minus 3. Substitute. N equals to minus 3. In my main equation, what is my LHS going to be? 2 into minus 3 square, minus 3, minus 3. Minus 3 square, 9. 9 twos are 18. Plus of minus, minus. Minus 15, minus 3. 18 minus 18, which is 0, which is my RHS. Therefore, n equals to minus 3 is the root of above quadratic equation. N equals to minus 3 is the root of above quadratic equation. I hope my children have understood. This was very, very simple. We have been given certain numbers, roots. We have to check whether they belong to our quadratic equation or not, or they satisfy our quadratic equations or not.